This is 6.5, solving exponential equations. An exponential equation is an equation in which the variable expressions occur as exponents. So variables will be in the exponent position. The property of equality for exponential equations says that if two powers with the same positive base b, where b is not 1, are equal, if and only if their exponents are equal. So I have b to the x equals b to the n. This means that x equals n, so their exponents are equal. B must be positive, and b cannot be 0. So if I have 2 to the x equals 2 to the 5th, then x equals 5. This if and only if statement is like a two-way conditional. So if the bases are the same, then the exponents are the same. If the exponents are the same, then we know the bases are the same. So we are going to solve each of these equations. 4 to the x plus 1 equals 4 to the 6th. I know that they have the same base, so I'm going to set their exponents equal to each other. Now, solve for x. And we find that x equals 5. If we have 12 equals 12 to the 4x minus 7, this 12 has an invisible 1 on it, so I'm going to set 1 equal to 4x minus 7. Then solve for x, and x equals 2. If I have 3 to the 3x plus 1 equals 3 to the 12x, they have the same base, set their exponents equal to each other, and solve for x. And here x is equal to 1/9. If I have 2 to the 2x equals 2 to the 5x minus 9. Again, they have the same base. Exponents are equal, and now I'm going to solve for x. So this one, you could move the 5x over right away, or you could move the number over and then move your 2x over. Either way, you should end up with x equals 3. So that's if the bases are the same. Now if the bases are not the same, we are going to rewrite so that the bases are the same. Simplify if you need to, and then solve just like we just did before. So if I have 4 to the x power equals 64, I can rewrite 64 as a power of 4. That's 4 to the 3rd. Then I'll have 4x equals 4 to the 3rd. The bases are the same, so set the exponents equal to each other, and x equals 3. For this one, I have 9 to the x equals 3 to the x plus 4. I can rewrite 9 as 3 squared. Then I need to simplify this 2 and the x. If it's a power to a power, you multiply. So I have 3 to the 2x equals 3 to the x plus 4. Now the bases are the same, so set the exponents equal and solve for x. So I have 25 to the x plus 1 equals 5 to the 4x plus 10. 25 can be rewritten as a power of 5. Then when I multiply, this 2 gets multiplied to each part. So you have to distribute it. Now I have the same base, so I can set exponents equal and solve for x. So if I have 1/2 to the x power equals 4, I can rewrite this 2 to have an exponent. That'd be a -1. Then multiply -1 times x, so I get 2 to the -x, and now I have the same base, and I can solve for x.